yeah, it's we've been just trying to get these research forums going. We got picked up for the Air Force Academy again for a space domain awareness project. So that was awesome. I'm gonna mute here for a minute and then start managing the room on this side. But yeah, we'll talk some more.
All right, sounds great.
Well, let's go ahead and get started. So my name is Mike Pritchard. I'm the Associate Dean for Research here at the Salina campus, and we are going to be doing advanced air mobility systems with Dr. Khan. So I appreciate everyone being here today. I've also got a really, really great crowd today, well attended. So I really appreciate it. And then I'm going to hand this over to Dr. Khan.
All right. This is Saeed, and I'm glad you guys showed up today. Despite all of the cancellation notices that you received. So one of the things that I'd like to start off with, and Professor Pritchard will use a mallet on me if we don't finish within 30 minutes, right? So I'm trying to make it brief, right? And you're going to indicate when I need to finish, right?
Yes, that's correct.
Okay. So first of all, I'm talking about the Certificate in Advanced Air Mobility Systems. And for the agenda, we go over the certificate fundamentals and then essentially spend a little bit of time talking about some things which are going to be fairly interesting to work on for research and other things later on. Okay, so moving on. Okay, so I suppose all of you know what AM is, but I want to point out that this is the best time for us as a school to hop onto the AM train, so to speak. And the reason for that is pretty obvious. If you look at the time frame, maturity time frame, it's as discussed by workshops, is somewhere between 2035 and 2040. So this is a time to assist with the development of this technology. And regarding this technology, the other thing is, if you look at our certificate, which is actually 12 credits, so we got a certificate that's 12 credits, but I mean, it can move into our integrated system design and dynamics master's degree, and well, all 12 credits would count for that for the master's degree. And so it's people might want to start with the certificate and go on the other way. Now, who's the certificate for? And I would say, you know, any graduate or almost graduate should start thinking about something like this. I would have hoped for more students today, because they're students from all of our technical divisions like MET, ECET, ET, Design and Integration, US operations should also be. In fact, students would be the ideally suited for this, because they're far younger than us and they will be surviving through all these changes that are coming up. So yeah, we want to attract more students. Hopefully we will at some point. So the next thing I want to say is, we are actually looking at the NASA AM program. And I want to read through this one more time. FAA also uses or is trying to leverage this program into the building of the AM system. So there are 5 different pillars, and as a school, I think we have the ability to touch upon all of them through our colleagues and everybody. So moving on. All right, so here is a little bit of description about the degree itself, the certificate itself, sorry. So you've got like 5 different pillars of, and so we designed the certificate based on like two different things. One, to provide, if you see the bluish component, provides all of that material that is like, what everyone needs to know about before starting on any serious AM work. And the green part is primarily based on, in this particular case, this particular system is based on communications, wireless communications, and regular communications or whatnot. I'm going to move on to this slide, which shows you how intrinsic the communication system is to the AM plans. Okay, so this is taken from the automated flight and contingency management notional architecture from one of the workshops arranged by NASA. And if you see what we have here is all forms of interested things that apply to our automated flight and contingency management infrastructure. Okay, so moving on further. All right, so I think I was going to talk a little bit about a few new things here, like going back to the design of scenarios. If AM is supposed to work properly, then the ability to run simulation in urban scenario is very critical to that. With all the possibilities of things that go wrong, we'll talk about the things that can go wrong in a little bit. And then autonomy, it's big, right? Autonomous systems is, see, initially, of course, many of you may know that the AM system is going to have a pilot in command, but ultimately it's designed to go to where it's a completely automated system. So that's maybe by 2030 or something like that, it's going to complete automated system. But our autonomous system includes a lot of things. The algorithm needs to be working, but also the sensors and the devices that go with it need to be working. So that's very big. The other thing is electromagnetic threats posed by jammers and things like that. We also have to keep in mind, and those are all areas in which very important research needs to be done before the AM system can actually take place. Another area would be corridor design. A corridor design, I had a slide on that. Okay, so if you look at air corridors, obviously you don't want one air taxi flying in randomly. You want them designed in such a way that they can, you have traffic following each other in an eastbound, westbound direction, and also having a elevation where you do roundabouts and things like that. The other thing is we talked about vehicle-to-vehicle communications, as well as the importance of that, especially during air hazard time. So you're going to have ground-to-vehicle communication, as well as vehicle-to-vehicle communication. So if you're following another aircraft and there's all of a sudden one aircraft sees some sort of an obstruction or hazard, you'll need to inform the others, and vehicle-to-vehicle communication would be very important for that as well. Okay, and here's where I think some of this certificate fits in very well. That is the CNS, or Communication, Navigation, Surveillance, CNS information infrastructure. Remember the UAM, which is now AM actually, ecosystem goal is to have that somewhere in the time frame of 2026 and 2027. And we think this is a lot of opportunities in that particular area. Okay. Moving on. So I attended several workshops that NASA has, and like this was the one about automated flight and contingency management ecosystem goal. I was like, this is not the latest, but this was at least about in the time frame of January of this year.
So this was one of the NASA workshops, and like I said, there was about 15 top-level industry personnel as well as NASA staff in that particular meeting. And so they did conduct a poll to figure out what would be more important in this particular area of automated flight contingency management ecosystem. So they put a high priority on air-to-ground communication and data link loss, the detect and avoid system, and as well as human automation certification path for human automation system. So not surprising, any of this. There's also priority for AI, machine learning, GPS, and things like that. Moving on. All right, so some of the things that people doing the certificate might be able to work on or do research on later is air corridors, air-to-air communication or vehicle-to-vehicle communication, air-to-ground communication, detect and avoid scenarios, and the GNSS problem, jamming and spoofing and things like that. So if you are interested in any of these, then this would be a good place to, once you finish as a project, we can have projects in these areas for students. All right, so I've got a couple of examples here that I'm gonna just do a magnifying thing. So the first one is, this is a model of New York City. And here's a fly path of aircraft. And as you can see, there is, these are buildings, high-rise buildings. There's a lot of place for refraction, diffraction, multipath interference, and so forth. Let's go. And then if you look at, so basically this is a two-dimensional look at the path that the dotted line here, the blue line here, is the path which the aircraft is taking. And at the same time, on the right-hand side is how many satellites are visible and usable for them, right? So many satellites are out there in their, but many of them are going to be affected by multipath. Some are going to be blocked based on the building structure and stuff like that. And some of them are visible. And so depending on where you are, this might be a different thing. So I was trying to show an animation of this, which using a snipping tool and photo and animation using Photoshop and snippet tool. Totally unsuccessful to do that. But I've got like 3 different snapshots here, depending on the aircraft of plane. Okay, so if you're moving from, and this is within like maybe a few blocks in a city, right? If you're moving from this guy to this guy, as you can see, the picture, the satellite picture has changed considerably, right? And then if you go here, so within the same block, and this is where the problem is, you could have so many things going wrong, right? Not to mention there are people deliberately trying to spoof you or jam you as well, right? And so these are the things that you could look at as being something to work on as how to avoid all these problems. I've done some research in there. I'm not going to talk about it, but it's kind of an interesting problem. And so what do I mean about the aircraft traveling through buildings and stuff is that you're going to get a lot of things. You got to get diffracted rays, reflected rays, and you're going to also have attenuated rays coming to you. And all of that is problematic because if these distances are the time of arrival of a reflected ray, for example, is more than half a bit time at, let's say, a GPS L1 frequency, then it really messes with the error. So the error gets higher from closer. So you can even get errors that actually come from another aircraft that's flying in the same area, or even in the body of your own aircraft, you can get a reflection. See what happens, the ray after reflection changes its polarization, and it becomes rather a loss factor or an error factor increases with the reckoning. Now, I've got to say that, you know, navigation involves a lot of other things as well. You can have radar systems, you can have LiDAR, you can have other systems as well, and all of them have some vulnerability. So I'm just talking about the GNSS system here. Another one could be jamming and spoofing problems. And if you look at the spoofing thing, where somebody's deliberately trying to mislead you in your location, and then jamming is just interference. Now, jamming could be problematic when you for the defense sector, when you're using precision guided munitions, okay, PGMs, because it can alter the accuracy of where your bomb is or your missile is going to land and so forth. So jamming is also important, and we all know about the time when Iran basically spoofed a U.S. aircraft to land somewhere else. This is the Dallas-Fort Worth airport, and planes taking off between 10:20 a.m. and 13:20, and they're followed for like a 5-minute long trajectory, right? And so some a plane takes off, you trace it for like 7 minutes. Now, if you look at, I'm going to have to zoom this in. Right. So if you look at the red lines, they kind of indicate where suspected jamming is taking place. And no big surprise, within the airport, close to the airport itself, is most of the red lines showing up. And then, like as it moves away, and at a different time intervals. So jamming is certainly a problem for commercial aircraft today, and certainly going to be a problem for aircraft that is in the AM aircraft as well. All right, so another thing is, and I have about 5 minutes left, but so the other thing is, you know, vertiports. There's a lot of work can be done with vertiports, especially with provider of services who are currently in the business already, and hopefully they're going to be providing services for vertiports, which are small landing places or large landing places somewhere for AM aircraft. There are issues there that needs to be studied regarding to how do you charge this, how do you maintain this, what are the operations, and what happens with the microweather system in that area. Okay, which means like you can't expect the weather to be the same as what your weather report is in the morning, because microweather seems to affect these things as well. All right, so so this is a kind of a time when I basically shut up and open this up to questions, and I tried to very unsuccessfully draw some correlates. Okay.
Okay, I think we're back on. Any, how do I sound on your end, on the other side?
Good.
Oh, wait, sorry. Hold on.
It's good, Mike. We can hear you. Yeah, it was.
Okay, let's try that again. Now we can hear you. Are you muted? Sorry, Dr. Khan. You good? Any feedback? Sound okay? Testing 1, 2, 3. Anybody online?
You're good.
Okay. So, hey, real quick, a couple things to mention too. So this is a graduate certificate. I know we said earlier certificate in the presentation. So even though it wasn't quite clear, this is a graduate certificate. It does stack into the Master of Science in Integrated Systems Design and Dynamics. We also just recently started sharing some of the classes with the Master of Science in Aeronautics. So some of the classes that are in the AAM side can also be used as a specialization elective within the aeronautics program. So that's just kind of a more of a newer thing. And then I think before we open it up to the floor for questions, a couple things that I want to mention too from as Dr. Khan was going through that. Thank you so much for giving us that's a lot of great information. Was that question that I had personally was like, so in addition to the graduate certificate that we have, and this is active today. This isn't like something that is like we're thinking of or pitching. So this is already active. You can go on to salina.kstate.edu. You go to graduate programs and you see the advanced air mobility graduate certificate. You can apply today. So that's one thing I wanted to show, or at least say. But the other thing too is that what are we doing in this space outside of the graduate certificate? And I think people, for those that are online as well, one of the in here is we actually are getting a Jetson 1. I know I've said it. I know probably some people are like, what is a Jetson 1? But it's a single-seater quadcopter, like a human actually gets into it. And it's got some big motors on it, right? And it gets you up to 1,500 feet, 60 miles an hour. I've said it over and over again, 20-minute ride time. But it's an experimental aircraft that allows us to actually start to get into this space. We already purchased one. It's coming in January. We're on the list. The manufacturer sold out, of course, all of 2023 and 2024. So these are kind of neat. There's three of these aircraft are coming to Kansas. So the good news is one of them is coming to our campus for us to be able to not only use for what it is we're doing here, from an operational perspective, but an experimental perspective, from a research perspective. It's a lot of opportunities. So I'm pretty excited about that. And then, we've been having conversations with the Salina Airport Authority too, in terms of, because it's not just the airframe and the technology and all that. I mean, there's just so much infrastructure that goes into this, right? These are a lot of the aircraft we're talking about. They're electrical, right? So there's charging infrastructure, there's all kinds of urban traffic management things that have to be figured out. And so anyway, it's a lot to go into. And we are doing currently actively outreach to Joby and Archer right now. So I don't know if people are familiar, Archer's got a contract with United to fly out. Who flies out of Salina? United. So it's an area that we're trying to and we're on a great route too. We're close to Wichita. We're a hop to Kansas City. So we're on a really great route to be able to make some stuff happen here, especially on the AAM side. Okay, so with that, that's my extra little bit of salt on the recipe. So I guess we'll just open it up to questions. Hopefully everyone can still hear me. Questions? Oh, Fred.
Yeah, I just wanted to know if we're going to have access to the slides, and if on the website you mentioned we could go look at the AAM program, are the student learning outcomes posted there?
Yes, they are.
So if the student learning outcomes are there, I'd also like access to the slides if I could.
Yeah, we'll get the slides out. We're also recording this video, so I'm going to make a nice little video, and then we'll get it posted so that everyone, and we'll actually be sharing it more broadly as well. So there'll be all that. Yeah, that'll be great.
Mike, you might want to talk about the interrelationship between at least three of the certificates.
Absolutely. Thank you, Professor Nichols. Yeah,
And
and so,
I'll
oh,
try
sorry,
not
go
to
ahead.
decline anymore for you.
So, we also have, in addition to the Advanced Air Mobility Program, we also have the Space Systems and Operations Program, the Aerospace Cyber Operations, as well as the Cyber Human Systems grad certificates. All four of those bolt into and fully stack into the Master of Science in Integrated Systems Design and Dynamics. So that's thanks. That's a good call out. We actually have a couple more grad certificates that are coming in online too. One in spatial computing, and then another in machine learning later this year that's coming online. So that's so more fun stuff for us to be noodling on for Salina. I think Chuck, you've got a question. You've been patiently waiting. I'll hand it over to you.
Yeah. Hey, first off, thank you very much for the presentation. The question is a rather simple one regarding the earning of the certificate. Are all the classes required in that certificate, are they in person or can they be done virtually from a distant location?
So they're 100% online. The grad certificates, the AAM grad certificate is 100% online, as well as the Master of Science that it bolts into is 100% online as well. Yes. Yeah.
Thank you.
And to add some extra color to that, the courses are in 8-week formats. So the way we've got it structured is there's 3 credit hours in the first 8 weeks, 3 credit hours in the second 8 weeks, and then that wraps up your fall semester. Then you switch over to spring, then you rinse, wash, and repeat. 8 weeks in the first part of spring, and then another 8 weeks in the second part of spring, and then that gets you your 12 credit hours, and you got a grad certificate. So yeah.
Is NASA offering something like this, and is it is it free for students?
Okay, so how does our certificate compare with NASA? Is that what you're asking?
Yeah, that's right.
Yeah, well, that's I'm just looking at the slide right here, and let's go ahead and I'm gonna move the thing here. Okay, so what we got is we've got these NASA pillars, right? So, for example, design, manufacture, system readiness of AM vehicles. These are the kinds of things that could be considered a part of that particular pillar. AM 601 touches on these, AM 605 touches on these, right? And then, and so the whole chart, when you get it, you're able to see how this compares to the NASA pillar, 5 NASA pillars, right? So, oops.
Okay, yeah, okay, I understand now. Thank you, Saeed. Yeah, thanks.
No, that's awesome. Chuck.
Yeah, I hate to capitalize on it. Another question I have is regarding prerequisites. I'm not in this field, the aerospace field, but I have done this operationally in previous positions. And I was wondering, are there any prerequisites prior to taking 601 through 801 regarding earning of the certificate?
Okay, Chuck, the way this is program is designed is the first 2 courses, AM 601 here. The first 2 courses, AM 601 and AM 605, are supposed to be fundamentals associated with AM communications. Are the next 9 credits are for. So here's my point. If you're coming in with 0 background in AM communication systems, we can get you through the program because the way the courses develop here are designed. So, for example, if you look at AM 732 and AM 762, those are like the kinds of coverage we need for doing our project course, which would be AM 801. So yeah, I mean, I don't think prereqs are going to be a problem. And then there's always the admissions question, right? So
Yeah, there's no prereqs outside of having a bachelor's degree. So as long as there's a graduate school requirement that we have to have the incoming students into all the grad certificates, and or because you can dual enroll as well, into the master's programs, whether it's a Master of Science in Aeronautics or whether it's a Master of Science in Integrated Systems Design and Dynamics. If you tackle this, you can all that it's helpful to have the industry background, of course, but a bachelor's degree with a GPA of 3.0 or better will get you through the process. Of course, it still has to be evaluated, but that's really all we're looking for on our side.
Yeah, currently I'm in a PhD program
Yeah,
in
that's-
Manhattan, so it's not related to this field, but this
Right.
field does have significant amount of interest. So it's a
Yeah.
reapplication process.
Yeah. Oh, sorry. Say that again, Chuck.
Would I be required to reapply because I'm currently accepted in a PhD program here?
So
Yeah.
yeah, that brings up, I'm actually working through a process, and this is something with the grad school we're working through, that if you've already applied to a grad program and you apply to another one, that you get the fee waiver for the application. But right now, there isn't a fee waiver on it. So you for every program that includes ours, that includes Manhattan, you have to pay the fee for the application. I will say what we have had happen, and this is something that we've seen in our grad certificates, is that they can be used as elective credits for your respective PhD program. Of course, you have to get that cleared with your major professor in your department, but they can be, we actually have had that happen where people come through and take our grad certificates, and then they get a little extra specialization within their PhD.
Yeah. Thanks for the answer. And Dr. Khan, you better be careful though. You know, my wife has said I'm mighty hard-headed, so I don't know if you could get me through this system.
Did you want to? Oh, I'm gonna pass the mic back over.
Jack, not only can I get you through this system, I can get your colleagues who are also retired military officers through the system. How's that?
Well,
And you can tell her that my regards as well. Give her my regards.
Will do. And like I said, I'll pass this on because there's a lot of us out there that have had experience with the various systems that our services use, and they do still have interest in this. So I appreciate what you guys are doing. This is really cool.
Yeah, yeah, yeah. It's got a lot of legs to it. Like right now, we've got a project with the Air Force Academy that's on the space side of the house, and space domain awareness specifically, and with the astronautics department out there. And I know I've said this a few times, but I mentioned that because there's other opportunities like that with advanced air mobility, that we can take this to on the Army side as well as the Air Force side. And there's so many different angles to this. It's not just on the system side. There's an ops side to it. There's also because these airframes are really lightweight, there's an advanced composite side to this, which we could potentially explore, because well, we do advanced composites here. So that there's some interesting angles outside of the A&P area as well, because it's just, again, there's a lot of different ways we can tackle this. So, but out of curiosity, I'm curious about some students that are here. I'm assuming students. So I want to hear, just give me a quick intro. I'd love to hear a little bit. Where you from and name and where you're from.
Yeah, my name's Ethan. I'm from McPherson area, and yeah, here in the electrical engineering program.
What brought you?
I have a class with Saeed Khan, and
Extra credit.
Very good. Extra credit. Extra credit.
Hello, my name is Connor Ewing. I'm from Chicago, and I'm in the UAS program here, which is the reason why I came here to this meeting, because it had to deal a little bit with UASs. So
Appreciate it. Any students from online? Chuck? No.
Yes, I am here.
Yeah, no.
I'm in
program.
I'm in the PhD program for history.
Oh,
So,
nice. Very cool.
So, but like I said, this has been based on the application of UAS in various theaters of operation, as well as controlling multiple platforms. And Dr. Khan had kind of sparked my interest in this stuff again. So that's kind of why I'm here. And it really isn't for any young people out there. This is going to be the future, because the applications for civilian and not only military are immense. So it's getting in on the ground floor is where to be.
Totally agree. Totally agree. Okay. Any more questions here internally? A self question, a recursive question from Dr. Khan?
No, I was just going to say that this is so good for our students. They're in the right time of their lives to move into this exponentially growing field. Okay, and it doesn't matter what your major is right now. You can still take a certificate and fit into the industry as well. Thank you.
Hey, have a good one. Thanks, everyone. Take care.